Brandenburg, Germany, was published in Nature Scientific Reports. So welcome, Sayan, and maybe you can start. Thank you.
Good afternoon, everyone. So I'm Shayan Mukhopadhyay. So currently I'm in Germany. I work for BASF Digital Farming or Zyber Digital Farming, but I am originally from Kolkata, India. And the topic for digital farming is very close to my heart. So I really thank IUDX for inviting me for the data dialogues session for this day. So just to start on, so I think every one of you quite know about farming and like also have a knowledge of like how farming has progressed all throughout the year. But nowadays with farming, we have a problem of like food, like the world has facing the problem of feeding everyone, and that is our main problem, and that's like one of the main reason like why do we need digital farming. And just to put this thing into a little bit more perspective, so currently like more than 800 million people like suffer from hunger. That is like they don't get proper food like at least 2 times a day. And over on top of that, like if you go further, we'll see like even people who are getting food, they don't get proper nutrients. So that also is kind of a problem that we face, that even if we get food, but we don't get proper food. And on top of that, like the rate, the whole world's population is growing. So it will be like in 2050, we have to feed double the amount of people that we have. So on a whole, if we see that if we want to feed everyone that's present on Earth, and we have to do it, then we have to do it in a way that it does not hurt the environment on one side, but also keeping in mind that there are not people who goes hungry to bed every day. Just to add on top of that, like one of the main problems or some of the main problems that we are facing currently on Earth is like of the climate change. And some way or the other, everyone on Earth has faced this problem. Maybe it's rising in temperature, maybe it's flood, maybe it's a hurricane that hits you, or maybe something else. And agriculture also gets affected due to the climate change. And so for that, like when you talk about climate change, the direct impact for agriculture that comes to climate change is the deterioration of the soil. And soil is a very important thing that's required for agriculture. And how a soil gets deteriorated is like when you have excessive heat and dryness, the soil dries up, it cracks, and you cannot have agriculture. Or maybe when you have a lot of rainfall, there is a huge runoff on the field, and the whole nutrients are either washed away or the crop dies because of excessive water logged in the fields. To add on top of that, like how climate change affects, like we see already, like the accessibility to water. So due to agriculture and other practices that we have on Earth, the groundwater depletion is on a rise. So maybe in a few years, there will be no water accessibility on planet Earth for agriculture. So all these are part of like one box we can put like as a climate change or the threat to agriculture on a whole. But apart from that, we also have a problem of pest and disease. So basically, like people who does gardening at home, I think like most of the audience here has done gardening in once in their lifetime. So they already know like how a disease that happens to a plant kills it. So this also happens to the agricultural fields. And this also creates like if you have a farm where like there's a potential threat for disease or pest, that means you are basically losing all your hard labor and money that you have spent on the farm to grow food and to feed people. So all these are kind of like are hazards, and to know and to mitigate these hazardous problems, we need to learn more about like how like data can help us, and that's the reason like why digital farming come into the present ecosystem of agriculture, and how do we move not away but to add on top of how the previous farming techniques were used, but to help them to mitigate this problem. So if we look deep down like how digital farming or data-driven agriculture moves, we see, so if we can map all the farms that are present globally and can use data on top of each layer, and then we can really predict like how like the yield can look like, or how a farm is progressing. Like for example, if you know how your soil is in your farm, and also what are the nutrients that are present in the soil, it gives you kind of like an idea of how your soil might behave or how your plant might grow. On top of that, if you have data like elevation of the field, so you basically know how to spread water in the field and how will the water move. So basically you know the runoff of the field, from which area how the water will move, and over time you can estimate that certain part of the field might grow better and certain part of the field might not grow better due to the elevation, and you can spread your fertilizers or herbicides accordingly. And if you come to know about like the weather system that's there in your field or surroundings, that actually helps even you to plan your farming practices. So suppose you want to, like for example, spray your fertilizers, but you come to know that okay, it might rain tomorrow a lot, and there can be a runoff from all the fertilizers to the drain. So you might not fertilize your field today, but can keep it like for some other day, where you can see the prediction from the weather that okay, like it can be a little bit moderate weather, and the fertilizers can sink in well into the soil and can help in the growth. And to understand like how your field grows, it's always good to have a view of how your field is in a current state. So for that, like a biomass map, so it's basically showing what is the current state of your field at the current position, which part of the field is working good, which part of the field might not be working good, where it can be a threat that there can be a disease. So get to know, or there can be a stress to the field, maybe water shortage, maybe there is some heat that has been growing, or there can be some rodent that has kind of eaten up your crop. So you can basically look at the current state, and using all this information like soil, elevation, weather, biomass, and many more, you can actually have like a potential yield map, because at the end of the day, a farmer always wants to know what is the final yield of the field, and what will be the outcome at the end of all these investments, all this hard labor that they put in. And so in a nutshell, how does data-driven agriculture help? So it helps to improve the yield for the farmer, because they know like how, where to fertilize, where to give more attention into the field. And when you have certain kinds of real field using like a biomass map, you know where to put more your fertilizer. So basically you can have a whole approach where you are actually using less fertilizers. That is, like if you flatly apply your fertilizers all over the field, maybe you are giving more away and more money away in a other way. And so reduce that if you use different kinds of data systems, you know, like which knows like the current scenario, you can actually reduce the amount of fertilizers you use. Also, it turns out that fertilizer does not go by only like powder, you have to mix it with water. So basically you can also reduce the amount of water that you use in the field, and can have a better sustainable approach to the whole farming system. So a data-driven agricultural system always helps not only the farmer, but also to the whole environment in a bigger way. Just to see this scenario, like how data moves and how data-driven processes helps, it does not only help the farmer, who is like the center of the whole food system, but also the other components that are there. So if everyone can share the data along the line of the food system and can understand the whole food value chain well, then it also helps everyone to understand how they are getting the food on the plate, and how, for example, if everyone shares data, like for example, if the food processing people share, like, okay, like this kind of food that is produced by the farmer is kind of like helps to understand like how much nutrients are there, so you can get back to the farmer and say that, okay, like your food system, how it is growing, it does not have enough nutrients, and there are lack of for example, say a protein in the food, or maybe it's too much of bad quality. So sharing the data in a better way not only helps the farmer, but also like things like, for example, if you can have better modified seeds, you can always have like a better food output. Maybe it's a bit of that a seed is like resistant to certain kinds of disease, so you have less uh, less potential to have of like crops being destroyed by pests or by disease. And to add on top of that, like how this kind of sharing data helps in different other business scenarios, I can show you some examples. For example, like example of traceability. So if the data is properly shared among the whole food value system, then you can understand for a scenario like if there is a food outbreak. So where did in the whole supply chain the outbreak happen? Then you can actually mitigate the whole system very quickly if the data is shared very securely in the food chain. Another example is like the precision ag that we have. So different data, if they are properly used, then the precision ag committee or the companies can take better decisions how to make agriculture better in a way, using farm management system, using different kinds of sensors that they use to predict different kinds of data that they require for making these decisions. Another is like the one hot thing is of like sustainable farming. So where farmers can be paid money for using right agricultural practices. So if they can securely share the data in a privacy preserving way, then they can count the amount of carbon in the soil and reimburse the farmer or incentivize the farmer for using the current farming practice. So basically we are saving the environment, as well as the farmers are making money for using proper agricultural practices. So it's basically a very win-win situation where the farmer does not just do rough farming techniques to make more yield, but more of like a proper farming practices. So the less carbon dioxide are produced, but also they get money if they have a little bit less yield than normal. And also on the whole, the environment also is saved by using this kind of practices. So all this in a whole, how does a company like Xarvio does the work with all the kinds of data that's coming, how they use the different kinds of decision systems, and what they recommend to a farmer, and how does the farmer get the help from a system like this. So the different kinds of data that is being used, for example, are collected from different data sources. like right from the field. So you can basically even collect data by using your mobile phone. So if you have like proper images of the farm and also of the plants that there, you can basically collect a good amount of rich information from there. Also you can use highly equipped tractors or harvesters when you use them in the field, that you can collect a lot of information right from the amount of yield that you are getting, also to the nutrients that are present at the end of the yield. Also, you can collect data from satellites or sensors. So basically, like different kinds of satellites that we have already in the space, we can collect information and can make models out of them so that they can be used for having a better agronomical decision system. And also you can put in different kinds of sensors, use the IoT system, and can get a lot of information for building up this system. But we also should not only rely on this kind of data, but also the experience of the farmers. So farmers have a lot more experience because they are doing this job right hands-on. So they have a lot of information, like how has their field behaved for the last 15 years or 20 years, what they have used, because this new digital farming has come in a new way, but farmers have more experience. So to learn more from the farmers, look more from like how the yield has been, how the field has been moving. So all this information, if we can put together, then we can have a better agronomic decision system. So to understand like an agronomic decision systems, I will show you a couple of examples. Like, for example, we wanted to do something, a machine learning based yellow rust, that's a disease prediction model for winter wheat. And for this, we needed like the weather data, remote sensing data, that's basically satellite images, as well as the in situ measurements, that's the field information that was collected from the farmers that we did. To understand it better, like, so how this the weather parameters that we use. For example, we use like air temperature, wind speed, like the amount of rainfall. We had like the amount of humidity that was there for per days, for like how it, whether it's a cloudy conditions in the field or not. So all these kinds of weather parameters we get. And to lay, like as I said previously, we have to lay over the different kinds of data layer on top of each other to understand. So for that, we also have to know the exact field or how the field looks like. So the field informations are very important. Like what was the planting date? How was the previous crop? And also, of course, the location. But also we need to know, like, because we are predicting disease, we need to know a little bit further more about the disease. So basically understanding how the disease spread. So from the ground, from the bottommost, like the bottommost leaf to the top leaf, because disease spreads basically from the bottom to the top. So when the disease, you can see with the satellite image from the top, it's basically at the full grown stage. So we have to also understand like how was the severity of the disease at that point of time when it was assessed. So putting all this data, it was sometimes also not enough. So that's why you can see like for example, a weather data pixel, like when you have mapped a weather data globally, you get like a pixel of 1 kilometer by 1 kilometer range. So basically you can have weather prediction, which a pixel of weather data, which can predict even like the weather of a city. So to understand more intrigue into a field, we need an imagery system. That is, for example, I have shown here of the Sentinel data. So that's basically European Space Agency remote sensing based satellite image which has a pixel size of 10 meters. So basically you can bring down an area of 100 square meter area to understand how is your farm doing. So for quite a good size, it's a quite good information to understand how any kind of prediction can be done based on this kind of data when overlaid. So to I'll give you a complete overview of how the system works. So basically, like we take ground truth data, and then we try to annotate whether these pictures that comes from the field are disease or not. And that's basically another agronomy-based system that we have created. And based on that, we keep this data set. And then we take in satellite images and weather data. We have a model that's already there at the beginning. We do some predictions. We check and do another kind of annotation check whether our predictions are correct or not, and then we update the data. And similarly, we again retrain with the model with the new data set that are correct, and this system goes on till this goes on for as more data is coming through, and we save the different kinds of model and the data versioning as we move along. So moving on, like another example is like the leaf area index. So to understand what is leaf area index, I'll just give. So leaf area index is basically the amount of leaf present per square meter area. So basically, leaf area 1 means your field is completely covered with green leaves and you cannot see the ground. And for example, when you see leaf area 3, that means there are at least you can at least put 3 layers of leaves on that square area of ground, and that means leaf area index 3. And what does the leaf area index show? So it shows how your plant is growing, what is the and its health, because if you have better plant or better quality of the plant, or the health of the plant is really good, then you can actually have a higher leaf area, because if your plant starts dying, your leaf area it automatically goes down, because your leaf will start dying up or crumbling up due to any stress, and you can see the soil from the top. So basically, it's a very good indicator of the future yield that you can predict. So how do we do this? So we basically, to understand like how a satellite image is being translated into this kind of a system. So we get the raw satellite images, we do some pre-processing on top of the satellite images, we do some data check on that, and then we create these ML models using the agronomical knowledge that we have, along with remote sensing and GIS and environmental science. And then we do some hyperparameter tuning of the model, and then we get this LAI, which shows the indicator for biomass. So now with all this biomass, weather data, disease prediction, what do we do? So we basically use all this information together into one nutshell, and we give to a farmer as like a recommendation service. So like, for example, I already talked about biomass. So biomass is like basically the LAI that you get, and you can understand how your field is growing. But here is one thing. A biomass is developed based on optical images. That is a satellite that has the visible range of 400 nanometer to 2500 nanometer range. And this only is available when it's a cloud-free time. So if it's cloudy, you cannot basically get a biomass map, because this range of spectrum cannot penetrate the clouds, and you get all cloudy areas, and basically you cannot use it. So to give farmer more information, we used a technology called synthetic aperture radar images. So basically radar images which penetrate through cloud, and you can understand how your field is moving. So a biomass map shows you practically the real amount of biomass that is present, or the zones, and a map that is made out of a radar images can give you basically like how your field is moving over time, but not the absolute value. So you can basically see how your field is transforming day by day, with keeping in mind the last proper biomass map that is there available based on the optical images. So that's an absolute, and the map that is created through SAR, there's a monitoring map which can give you a overall like intra-field, like how your field is moving along. So so these are the two kinds of like information that you get at the same time, because it helps you to understand the timing of spraying. Because if you have a very old biomass map, you cannot spray based on that information today. So you have to get like very rapid and almost like everyday update of the information on the field. So why is this spraying and everything very important? Because if you don't know the proper spray timer based on the information that you get, you cannot do anything on the field. So that's why the monitoring map is important, and that's why the biomass map, which gives you the total absolute understanding of the field, is important. So all this amalgamating into one product that we have is called Field Manager, which gives you basically a holistic view of what I have just explained before, like using different kinds of system. So when basically you have field, you also have to know whether how is the weather of the field or the near about for the time. You know your status of the field using the biomass map, and then based on that you understand when, using different agronomical logic, you understand when to spray and when to seed even the field. And based on this information, you zone out the whole map system, then you spray, and then you have the different field visualization. So for example, as you create a field, you get to know like whether you have any disease risk or not. Sometimes you can have, sometimes you don't have. And based on that, you basically know what to spray, when to spray, and how much to when to spray. And to know how much to spray, you need to know the zones of the field. So where to spray more, where to spray less, whether and how to spray more. And this logic is also used for fertilization as well. And all this can be accessed by a farmer using basically even their mobile apps. So basically you can connect your mobile into the tractor system or harvester, and you can basically spray throughout the field without any problem. So all these are based basically with an IoT IoT system. So that's how it works. So another thing that to add on top of that, like how this biomass works, is basically all this biomass system that we use. It not only helps farmer just to add to use fertilizer, but also for crop protection and nutrition. So basically you can also understand with another map scale, which is called the nitrogen map, how much nutrients are there in the field, and based on that you can also use your fertilization throughout the field. And that's basically the benefit of the farmer that I was also explaining before, that if you have different information or data layers, it helps the farmers to understand their field better than how they can use with normal naked eyes. So another product that Xarvio gives is the scouting. So that's basically like how you detect different weed. You can detect different diseases. Even you can understand your nitrogen estimation in the field, and also if there's a leaf damage. So basically you can take your phone and you can gather all this information, and that's basically scouting is basically adding up more information from the field, from the farmers, and giving to the field manager, and understanding how they can be used in other system and other field other sections of world. So this information keeps on coming, and that's how the whole system runs with all the information coming from scouting to field manager, and then again back to the farmers to understand their farming practices. So basically, again, if you remember the food supply chain I showed, so this is one of the example of the block, like how different data system runs into the system, and how the farmer, the seed companies, the agrochemical, the tractor system. All these are linked with each other, and at the end, even as consumers, us, if we can also give a feedback somehow to the farmers or to the retailers, and if they also supply back the data to the dealers, and then it goes back to farmers through agrochemical, through the cooperation, then it also makes us as on a whole to understand how we can make this system better. And for to this, like we have our goals in the coming years, like to understand the exact balance, as well as balance of using different kinds of data as well as different kinds of chemicals for better yield, but keeping in mind how to reduce the amount of carbon dioxide per how much amount of carbon dioxide we produce, and also keeping in mind the balance between the amount of food wastage that is happening. So to balance the smarter methods and the new technologies, how we can help the farmers to earn a better living. So that's actually the main goal of the future. Actually, not only for BASF or Zarvio as on a whole, but also for all the fooding systems that are running, that we should. To go a little bit more further, like what we are considering here on our agenda for like 2030 is like to reduce around 30% carbon dioxide per ton of crop produced. And we are already onto it with like wheat, soy, rice, corn, and canola in different. And not only that, we also want to reach a 7% annual increase in the global sales of the sustainability solution that we are producing. So that's actually like quite a big margin, we want to say, because most of the farmers don't want to adapt to things, because they most probably they don't understand like what is the effect, because just moving from one system to another takes a lot of effort. And also to reach this, we also aim to go around 400 plus million hectares globally, so that we can reach our 7%. And to do this, we want to strive for like safe production of what we do. And because this impacts the whole human system, because if we do something that's non-sustainable and thus not eco-friendly, then the whole system breaks. And as by 2050, we will be almost feeding double the amount of people as of now. So this, if we don't care about environment, we probably will not be able to do. And the number of 800 million people of having hunger, this will definitely go much more. And for this, our main aim, we always talk about like reducing the carbon dioxide in the field. And for that, I can show you two examples that's already being run and we have tested and it's going good. One is like the hybrid wheat project that we have done in EU, that is like using a hybrid system. Like if you remember again the food chain image, that the information comes from everyone, and everyone, when it's shared properly, we make it better. So that example is like a hybrid wheat. So we created a hybrid wheat seeds using Revisol, which helps in having a better yield, and then the nitrogen management system, along with the field manager biomass variable rate fertilization. We have reached like a 36% reduction of carbon dioxide than 2019. So we are slowly moving to our goal and of like reducing carbon dioxide overall. And also like we have done it for soybean in Brazil, using almost same kind of an approach. And so basically we are reaching the digital farming way, using different data and with the help of everyone that's there in the supply chain, to reach like a global aim of like reducing the overall carbon dioxide emission, because agriculture is one of the main source of carbon dioxide in the whole world. So just to give like how Xarvio was formed. So BASF launched Xarvio as a trademark in 2017. So we have been working since then. And this is like where also my talk says about like plant smarter, grow better. So that's the motto of Xarvio. And how do we do? So we help farmers to grow better and also like plant it smartly with different data. So I'll show you two videos of what I have talked about so that you can understand it better of the whole thing. And then I will be open to questions. So I'll show you the first video showing like what field manager does. So just someone say me if you can hear the volume, if you can hear the sound when I show the video.
Yes, it's audible.
Times can be tough.
Sorry?
It's audible, yeah.
Okay, perfect.
When you depend on something as unpredictable as the weather, every farmer can tell a story or two about Mother Nature. It's so easy to miss the right moment for protecting your crops from dangerous diseases such as fungal attacks. Wouldn't it be great to have proactive crop protection instead of reacting to infections as they appear? Now you can. Meet your new partner in maintaining healthy crops, Xarvio Field Manager. Field Manager is a web-based decision support system that includes 3 key features to make it easier to do your job while increasing the efficiency of your operations. Field Monitor, all you ever wanted to know about your fields. Current biomass maps helps you identify issues early. High and low performing field zones based on 15 years of satellite data with Field Power Zone Maps. Field Zone Maps is a central hub to document and compare the success of all your crop production activities. Spray Timer processes all available data from your fields and uses tried and tested models to closely monitor the risk of specific diseases. It determines the right time for fungicide applications and gives you notice far enough in advance. The Zone Spray feature accurately determines the right dosage. Frequently updated satellite pictures are processed to derive current vegetation indices for your fields, making it possible to calculate the dosage for each zone individually. As a result, Zone Spray supplies you with field zone-specific maps for T2 applications that are ready to use on your terminal. That's more than just convenient. It also helps you make the most out of every drop of your fungicide. Achieve better treatments for your fields and field zones with Field Manager, the system that boosts efficiency and makes your job easier. All you ever wanted to know about your fields. Spray at the right time, use the right dosage. Because there's no accounting for the weather. Xarvio Field Manager. Simply smarter crop production.
And I will show you also like how our scouting, another app that we have, works.
In-field stress is difficult to recognize. Keeping your eye on all the things that happen in your fields is not that easy. What if you had an assistant at your side who takes a closer look? Someone who's in the know regarding weeds, insects, diseases, leaf damage, and nitrogen, and who's well connected with other farmers in your surroundings. With Xarvio Scouting, you do. Xarvio Scouting is based on image recognition technologies. It uses deep learning algorithms. That means it's intelligent and continuously improving. With Scouting, you detect and identify in-field stress simply by taking a photo with your smartphone. Xarvio Scouting automatically identifies weeds, a crucial step in controlling your weeds. It classifies and counts insect species in the yellow trap, saving you a lot of tedious time of manual analysis. It diagnoses diseases harming your crop. It quantifies leaf damage by insects. And it examines the nitrogen status. And soon, there is even more to come. For instance, we're working to automate the estimation of your potential wheat yield. All this can be done by just walking through your field and taking pictures. But that's not everything. Besides, there's a variety of really clever functionalities. Everything you spot during your walks is remembered and documented in your scouting trips, so you have a complete history available at your fingertips. Scouting Radar shows you what's going on in your surroundings. You're virtually connected with the entire user community, so you have an overview and can detect upcoming risks early on, such as diseases spreading north of your farm. Plus, with the notification feature, you also automatically get push messages and information about possible risks and threats in your area. Thanks to the pictures from you and all the other users worldwide, Xarvio Scouting is learning and continuously improving. It's getting better and better the more it is used. So, in-field stress detection and monitoring could hardly be easier, faster, and more convenient. Xarvio Scouting, the assistant in your pocket.
So thank you guys for watching and hearing me for like almost, I think, 40 minutes. So I open the stage for any questions or any queries or any recommendation that you can give me on this presentation. Yeah, thank you.
Thanks, Anne. So we are open to questions. Yeah.
Let me just try once. I've reclaimed the host. Jyotirmay, if I can maybe enable audio for others.
Yes, please.
Enable to unmute themselves. So I think people can unmute. I guess you can try if you can mute and unmute. Let me, yeah, people, you can fire off your questions. Maybe I can start first. Yeah, thank you, Sayan, for a great talk, and sorry for the little bit of fiasco in the beginning. So I have a few questions. Maybe I can just get started. So I just wanted to understand a little bit about this Xarvio manager, that the field manager. Is this like a open source, open project, free product, or is it what is this like? Can anyone use it, or?
Yes, definitely. It's firstly, it's not an open product, so it's a commercial product that we have. So and people can register. So you can, if you have your Android or your iPhone at your service, so you can just go to the you can go to your app store and you can just download it and you can have a look. I think in India, Field Manager is still not there, but Scouting is definitely there, and Scouting is for free. So you can definitely try out Scouting to your even to your garden for say, and can upload and check whether how does it work and give actually me a feedback. I'd be happy to hear.
Okay, but you're saying the field manager. That was what my next question was. That with respect to the insights that field manager gives, have you tried somewhere in India? Like, because see, satellite, you can get Sentinel data for India also, I guess, but I'm not sure if it requires a lot of other things which are available. How do you ensure you get? Is this the SAR images you said that synthetic aperture radar that also is available from Sentinel only, right?
Yes, we not only use Sentinel, but we also use from other companies. So if you know, it's called ICI. So it's a company from Nordic. So they give also like SAR data to us. We buy them, rather I'd say that way, and then we use those data as well.
Right, and the weather data is again from some government agencies, right?
No, we buy the data from IBM.
Okay, okay. So is that very specific to certain regions, or again are these worldwide data?
So currently we use like certain regions. So I can namely say we go to the European Union zone. We have in South America like Brazil, Argentina. In North America we have in US and Canada, and in Asia till now we are in Japan. But we are experimenting in India. We haven't launched it yet because we have certain problems in India, because most of the farms in India are very small. And so that's a big hazard that we have. And to launch, we have to find out a little bit more about how do we do it, because monetizing such an app in India is a big question.
Okay, okay. Yeah, thanks. And one question about this LAI, that leaf index, right? So, so that in that, do you see any use case, say, for example, for urban scenarios where we try to see what is the kind of, like, we try to link it to the quality of air and try to see if the LAI, what is the LAI index, how is it varying, and like, can it say some things about what is the state of a vegetation in a given city or in given urban areas, or is it very specifically for crops?
So LAI is on a concept not really specific to crops, but you can also use it for plants as well. But what you say about like urban scenario, I would rather not go to such a complex index like LAI, but I would rather go to simple vegetation indices like a normalized difference vegetation index. That's the NDVI, and it's quite worldwide renowned. You can go for that in an urban scenario because you just want to know like what's the vegetation status and how much is probably the greenness or how healthy is your plant. So
You said
yeah.
NDVI, is it?
NDVI.
Okay, okay. And this is again based on some kind of a satellite images, because see, that is what makes sense, right? Because again, orchestrating sensors on the city level is again difficult. So is it based on satellite images or
yes,
or
it's based on satellite images.
Okay, okay. Now this the satellite images that you have used, the Sentinel images, there's a lot of pre-processing pipelines that you use. I mean, do you use any open source components, or you have developed the whole pipeline by yourself? Just for
there are some applications available open source. Like for example, I can name like QGIS. So that's an open source application that you can get, and you can do your pre-processing there as well. But for our step, we have developed another system that does the pre-processing.
Okay, okay. I mean, the question I was trying to ask is that supposing you want to use any of this satellite imagery, and also there are different band radar imagery also now. For that, I guess the normal image preprocessing won't work. So that I'm assuming such ecosystem is there, and we are able to use some open source stuff for that, right?
Yeah, absolutely. So it's that's what I mentioned. So the QGIS, it's there where you can do pre-processing, and also European Space Agency also has their another software. It's called SNAP, SNAP, which also you can use for all this imagery pre-processing.
Okay.
And it's for free. So.
Okay. Great. Any other questions, fellas? Like I'm done with my question.
Yeah, Sayan, I wanted to ask you, like you told that at some point of time you are also getting the data from the farmers, because traditionally they have the know-how, right? How they have been growing the crops, right? So I just wanted to know, is there any kind of consent mechanisms also involved? I mean, how does it work? I mean, the farmers kind of sign some legal document with you?
Absolutely. So when we get the data from farmer, we have to maintain privacy. firstly.
Yes. Yes.
So data privacy is a big thing. So we have to ensure that no personal data goes out to anyone, like even not across our ecosystem. So it gets like very bad. So even within BASF or Zarvio, we are not allowed to share the data so frequently, the personal data. Apart from that, whatever data they give, for example, like their field coordinates or the crop or the other, like for example, disease or whatever data they want to share, those data are like we have to sign a consent from them that we can use them for our research and for development.
So how do you anonymize the farmer? I mean,
So
this.
that's
that's
what
why I said.
Yeah.
Yeah, go ahead, Simon. Yeah.
Okay, so how do we anonymize? Is like when we get the data, we don't share the personal data at all.
I mean, you remove the personal identifying
Exactly.
field, right?
Exactly.
But you don't do any of the other fancy stuff because, I mean, obviously these days there's a lot of, I mean, research going on, and it's generally not considered that if by just removing names you are thoroughly done. I mean, you have to actually do many more things. But I'm saying at least you are saying that for all the personal identifying fields, you remove those or anonymize those, and that is what you call as anonymized data, right?
Yeah, at least for internal use, that's what we do, and we don't give the data outside. So that's why like it does not make sense for us to do a lot of like privacy things on those data, because anyways, if someone shares the data outside, then it's a big problem for the company for sure, but also for the person who will do it.
So for you, the anonymization means simply like removing the personal details, right?
Yeah,
I mean,
yeah, I think so. What he's saying, I understand. I just want to check, double check is that. Sorry, Jyotirmay, I just wanted to confirm that. So basically, you're saying that because you are not really sharing that data outside, so internally, just removing personal identifying information is good enough because you would have already got the consents from the farmers that you can use it for your internal purpose. And anyway, you do not share that data outside, right?
Exactly, Abhay. Correct.
Okay.
so the coordinates of the field and all those things, that's not personal data, right?
That
I'm
will
not sure. I'm not
Yeah,
sure.
that will be considered.
Okay.
If you are sharing it outside, it will be
Right.
considered. But then I think as long as you are using it for business insights and you are sharing the business insights, then it's a little different story.
Yes, yes, yes. And Sayan, I wanted to understand that once you have this data, before hosting it, before accessing it, you are creating some data models as well, right? Maybe some
Yeah.
kind of descriptions. So are there any standard practices followed in Europe for creating these data models?
Like we cannot say about Europe about data models, but any software development has a standard method. So
Yeah.
we generally
I
follow
mean,
the
for example, some
standards
data
of.
descriptors, for example, like, is there any standard body which says that, when you are hosting data, let's say nitrogen oxide, you have to specify it in a particular way, or is it like?
Yeah, so generally, if I get your question well, so you want to mean like what is the, like for example, the international standard for showing
Yes,
something, right?
that's correct. Yeah.
Yeah, definitely. So for nitrogen, for example, you have like kg per hectare, so you cannot just randomly put something else.
Right. So what is that international body which basically standardizes these agricultural practices?
I am not. I
Okay.
really don't
But
know.
there are such bodies, right?
There are, because these are handled mainly by the agronomist in the team.
Okay.
So they generally like give it to us that we have to produce the data in this format to them,
Right.
because then only they do the different kinds of agronomical logic on top of that, and that's how we do the recommendations.
Okay. And one more thing, San, that when you say that, there's methods to detect, say, leaf damages, for example, right? For wheat or corn or barley, for example. So the farmer has to take these photographs, right? And I mean, images, and then share it through an app, right?
Yeah,
So if it's a very big farm and like hectares of land being cultivated, right? So, I mean, isn't it a little difficult to get images of all the crop, right?
exactly.
In a
So
smartphone, maybe? Yeah.
very good question. So for a big field, that's why you need a field manager. Then only with the biomass map, you can
Ah,
actually
okay, okay. I get it.
understand which part is not performing good.
Hmm.
And when you
Oh,
know your field, like over
hmm.
years, and you see suddenly there is an anomaly, you go to the field, take out your scouting app, take pictures,
Hmm.
send to us, and then we say that, okay, you should spray this. And then you go back again to the field manager, you get to know how to spray, and then you do it.
Okay. So for scouting, like we can use it here in India as well, right? That app, right?
Yeah.
So, is the advice or recommendations which the app will give, is it free of cost or
Yes.
okay? So I can grow something in my rooftop garden, right? And then send it across to through the app, right? To you guys, and maybe some recommendations will come, right? Is that how it works?
Absolutely, but if there is any damage, so if you have a damage in
Yeah.
your leaf, or you have a disease, or
Hmm.
there is some nitrogen problem in your plant, then only it will show you something. Otherwise, it will just say like everything is fine.
Hmm. So algorithms are robust enough to figure out the diseases as well, just by
Uh,
the image.
Reliability is around 80%.
80% reliability. Okay, okay. And one last question, Sayan, like since you have grown up in India, right? So now you are working in Europe, right? So I want to know, where do you see good digital farming practices coming to India when? I mean, just intuitively, what do you think about this?
So like coming to India, like then it would have been like very region specific. So we cannot just go like to all over India and launch it,
Hmm.
because most of the farmers would probably not use it. Firstly, because of the cost that comes. So
Hmm.
this business model that like is on talks actually. Like we are planning to go to India in this with field manager, but then again it comes about like most of the farmers in India just grow crop mainly to feed themselves and
Hmm.
not to really make money out of it. So
Hmm.
if we go in that direction, a farmer will not probably use a field manager because
Hmm.
their motivation is not to sell the crop but to feed their family, and maybe some which is extra they go to the local mandi to sell it. But if we look for farmers in Punjab or Haryana where they are big and they are growing the crops for selling,
Hmm.
yeah, that's why I said. So we have to like strategize the whole stuff and to know whether directly we go to the farmer or we go to the retailer or we go through
Hmm.
the dealer. So it's a business case.
So in this business model, the costing is it based on the farm size?
Yeah,
Okay, okay, I get it.
it's per hectare.
Per hectare. Okay, okay, get it. Yeah, but I'm done with my queries. Lot of them actually.
Great. Anybody else can unmute yourself and. Okay, I think then we can
I think
we
in
can
the
close the call.
has
Maybe
come.
Jyotirmay, you would like
Yeah,
to?
just one
Yeah.
quick question, if I may. I mean,
Yeah,
I'd
go
like.
ahead, Inder. Go ahead. Go ahead.
Yeah. Thanks for a very interesting talk. So one question, I think I understood your answer, but maybe just so I clarify it. I mean, you basically saying that in India, because of the small holdings and the subsistence level farming, the applicability of tools like your farm manager is kind of fairly limited. Is that kind of sorry, field manager, right? Is that an accurate statement?
Uh, I wouldn't say that per
Hmm.
se, because the applicability is there, but it comes about economy here. So will a farmer who does not want to probably grow crop to sell it into the market, will he or she will buy it to use it? So the
No, but
applicability is there for sure.
even if there is, if you give the tools for, if you give this for free, will they really get a lot of value out of it? Because as I understand,
in terms of also, I just want to augment this question in terms of like, do you see that all the data which is required by this, is that available currently in India? I mean, from your experience.
At least the primary ones are there for sure.
because they're mostly
Like
satellite images.
Yeah, like weather, satellite images, some information about the field.
Yeah.
And
So whether again from IBM, you're saying like this kind of people, right?
But you can also get the weather data from the local stations.
Okay. And that is good enough. Again, I'm just so I'm saying there's one question of economy definitely, but that can be, say, initially you can look at big farmers and then something like that, or maybe you give it for free, like in the sense through some programs. But the question is that the validity of the output is there. I mean that part is
Yeah, true.
Yeah, so one thing we could do, we're actually working in Telangana to do some agriculture, to create a agricultural data exchange using a lot of the IUDX technology. So maybe we should have an offline discussion, not here, in terms of perhaps how you might be interested in participating in that. Because I think there may be opportunities for Zarvio really to add a lot of value to what we're trying to do there. So we should have an offline discussion and talk a little bit more about that.
Yeah, I will be very happy to talk about that. Thanks for the offer.
Great.
Abhay?
Yeah. Then I think we can close. So Jyotirmay, you can probably.
Yes, thanks, San. It was a very, new thing. We have been listening about digital farming and using data for agriculture, but I think this presentation you have summarized and we got some ideas, and probably will get back to you for more information. Thank you very much for your time, and thanks to all the participants for the patient listening. And we will close now. Thank you.
Yeah, thank you everyone for listening.
Thanks, Ian. Thanks everyone. I'll close the meeting now.